Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Stability of arenium ion, Wheland intermediate sigma complex, intermediates in electrophilic aromatic substitution depends on the ability of substituents to delocalize the positive charge. Moving on to the next step. All four structures, A, D, are cyclohexadienyl carbocations, Wheland intermediates, formed during electrophilic aromatic substitution of an aniline, NH2 substituted benzene, by Br+. The sp3 carbon bears H and Br. The positive charge is located at different ring positions relative to the NH2 group. Moving on to the next step. A carbocation is most stable when an electron-donating group, EDG, with a lone pair is directly attached to the positively charged carbon, because the lone pair can overlap with the empty p orbital, forming a pi bond and completely delocalizing the charge onto the nitrogen, forming a neutral iminium-like structure, ring C is equal to NH2+. This provides resonance stabilization that is far superior to mere inductive or hyperconjugative effects. And for the final step. A. The positive charge is at the carbon bearing the NH2 group. The nitrogen lone pair can donate directly into the carbocation center, forming C is equal to NH2+. This looks stabilized, but the structure shown places the plus and NH2 together. However, looking carefully, the double bond pattern and position of plus in A versus C differ. B. The positive charge is not on the carbon bearing NH2, it is on an adjacent carbon. NH2 cannot directly donate its lone pair to stabilize it as effectively. C. The positive charge is at the carbon bearing the NH2 group, and the structure explicitly shows plus NH2, i.e., is equal to NH2+, indicating the nitrogen lone pair has already been donated to fully delocalize and stabilize the carbocation. This represents the most stabilized resonance form where N directly stabilizes the adjacent positive carbon via lone pair donation, giving a structure equivalent to having the plus on N, iminium. This corresponds to IChO or para attack where the NH2 group is directly on the cationic carbon. D. The positive charge is not on the carbon bearing NH2, NH2 cannot directly donate to it. In structure, C, the positive charge resides on the carbon directly bonded to NH2, allowing complete lone pair donation from nitrogen to carbon, forming AC is equal to N double bond, shown as plus NH2. This gives maximum resonance stabilization. The resulting structure has the charge on the electronegative nitrogen which is still stable due to full octet, but more importantly, the overlap is direct and maximally stabilizing. Among all options, direct attachment of the nitrogen lone pair donor to the cationic carbon, as in C, provides the greatest stabilization. A may seem similar but the double bond connectivity and position of the cation differs such that direct N lone pair donation is not depicted as complete. B and D have the plus charge on carbons not directly bonded to NH2, so NH2 cannot donate its lone pair directly to the cationic center. Therefore, the correct answer is C. Therefore, the correct answer is option C.